My friends, this little lecture is entitled Reading the Z-Score Tables Insight into the Standard Normal Curve. The dog shows the way. Go, dog, go. In this discussion, we're going to examine the standard normal distribution curve and look at finding areas under that curve. It's important for you to remember that the standard normal distribution curve is a normal distribution curve, but a very special normal distribution curve having mean equals 0 and standard deviation equal to 1. You notice this little picture here in the center. Do you see the mean of 0? And then you have 1, 2, and 3, which out to the right indicates that those are 3 standard deviations to the right, and on the left you have -1, -2, and -3, indicating that those standard deviations are below the mean. In the standard normal distribution curve, 50% of the data lie above the mean. Now, notice that I said 50%. 50% is actually 1/2 or 0.5. 50% of the data also lie to the left of the mean. 50% again is 0.5 or 1/2. In other words, to put it simply, 1/2 of the area is on to the right, 1/2 of the area is to the left, so we might say 100% of the data lie beneath the curve. The standard normal distribution curve has an area of 1.0000. This is the same as 100%. In other words, underneath this curve, there is one full unit of area. Half of it lies to the right of the mean, which is above the mean. Half of it lies to the left, which is below the mean. 50% to the right of the mean, 50% to the left of the mean. Those z-scores or values above the mean are positive, and those z-scores with values below the mean are negative. The z-score tables that we will look at are contained within the textbook which is assigned for this course. Now, those tables have a table 1 which gives the negative z-score values and a table 2 which provides values for the positive z-scores. To illustrate this graphically, observe these two curves. This curve has negative z-score values, and they will use table 1 because those z-scores are to the left of the mean. Now, that table will provide the area from the z-score back all the way to the left. And it does the same thing in the positive z-score tables. It provides the value from the z-score all the way back to the left. Table 1 you look at if you have a negative z-score, which gives you this area. Table 2 you look at if you have a positive z-score, which gives you this area. Table 1 has the value for the negative z-scores. You should see the negative values here. Those are negative z-scores. Table 2 includes the value for the positive z-scores. If you'll see the z-score right here going down this side with positive values. Now we're going to examine a z-score of 1.45 and see if we can use the table to locate the area which lies to the left of the z-score. If you'll recall, this is what the table gives you. From the z-score, it gives you all the area to the left. Since our z-score of 1.45 is positive, we will use table 2, which includes the positive z-score value. In order to locate an area for a z-score of 1.45, we will work in 2 steps. First, we have to start with locating 1.4. That's the first phase. After we have located 1.4 down the areas of z, we will read across to find 0.05. And if we go across on 1.4 and we go down on 0.05, it brings us to this value right here. When we find 1.4, then 0.05, we in fact have found the area for a z-score of 1.45. And lo and behold, look here, we found our area for 1.45 to be 0.9265. We've done well. We now know that if we take a z-score of 1.45 and locate it, we would go to the positive table, find the area first for 1.4, then look across to 0.05, and we have z for 1.45 of 0.9265. That means that this area out of an entire area of 1 is 0.9265. That is awesome. We will also make one very clever little adjustment here. Since 0.9265 is in fact 92.65%, we will begin to refer to these areas as percents. 92.65% of the data lies to the left of a z-score of 1.45. Of course, we have 100% of the data under the curve. We now know that 92.65% of the data lie to the left of a z-score of 1.45. Our question then would be how much lies to the right. Now the table doesn't give us what lies to the right, but we can be very clever and we can find out how much it is. To start with, there is 1 unit of area under the curve. So the entire curve has an area of 1.000. If the table gives us the area to the left of 1.45 to be 0.9265, then all we have to do is take 1 and subtract this amount from it, and it will give us what is left. That area is 0.0735. How clever. If 0.0735% of the data lie to the right of a z of 1.45, we can say that 7.35% of the data lie to the right of that z-score of 1.45. And to help you envision that 100% of the data lie under the curve, observe that to the left of a z-score of 1.45, we have 92.65% of the data, and to the right of the z-score of 1.45, we have 7.35% of the data, and that adds up to 100% of the data under the curve. You're back in the doghouse again. We've had a rough ride here, but we've discovered some very, very important skills. If you're going to master this course, you must know how to determine and find z-scores under a standard normal curve. You've done well, Pilgrim, to come so far, to have so much hair with so many after it. One of these days you'll figure out that that's a quote out of the movie Mountain Men. But for now, I'll leave you in the dark.